Okay, so okay, so this is the first verse from Aryabhata Ganitapada, in which Aryabhata salutes the planets and nakshatras or constellations of stars. And the translation that is given in Marathi is given by Shankar Abhyangkar, father of Sriram Abhyangkar. And at the beginning, Aryabhata salutes Brahma, who Brahma can be Brahmadev or Brahma itself, who is Prithvi, Earth, then Shashi, that is Moon, Buddha, that is Mercury, Guru, Venus, Ravi, is Sun, who is Prithvi, Puja, that is somebody who take to birth from Prithvi or Earth, and Mangala is supposed to be that planet. So, Mangala or you can say Mars, then Guru is Jupiter, Pona is Saturn, Bha is Nakshatra or stars, Bhagana is collection of stars, constellations, we can say probably Rashis also, which are constellations or collections of stars, like Mesha, Katre, and so on. Namaste, so he salutes him and Aryabhata to Iho. So Aryabhata tells us, Nigadati, tells us, Iho means, you can say in this book, that is Ganitapada, or Aryabhati as they call it, Kusumapura Abhyadam Jnana. So Kusumapura is Pataliputra or Patna in Bihar, and whatever Jnana or knowledge which is Abhyadam is respected in Kusumapura. So that knowledge Aryabhata is telling us. So that is the first verse. And who is Prithvi? Who is itself name? Who is Prithvi? And Puja is somebody to birth from who, that is Prithvi, and Mangala is supposed to be that planet. So, name is it is a short word. So, anyway, Aryabhata is for very short words. Special to no, I think it is I think they are always, but it is not used in the usual practice. That is true. So you can use with many other things. I don't know whether who is used in some other. Is there any similar word that you know? Bha is there, for example. Bha is nakshatra, which is used here. Bhagana. Bhagana is collection of stars. We can get some meaning of it. That's right. But Bha is used many times here in this context at least. So Bhagavan Namastu Karina, how is ha. That's all the repeated word. People say Rama, ha. Now, I remember Bhanu, so swimming is what is feminine. So I am doing what is the word? Vidalame can tell you. Vidalame is here, who is also. It will run like that. What happened there? This is Samaj. They don't use the. So, madam, you can always comment whenever we are having some difficulty or discussion going on, then you can give your opinion and comments. So, anyway, so this is these two short words are here. That much we have seen. Now, much Okay, so these are the names of the place values given by Aryabhata. Eka, Dasha, Shata, Sahasra, Ayuta. Ayuta is 10,000. Niyuta is Laksha. Laksha was not used by Aryabhata. And it was not also in Egypt. But it was used for the first time, as I know, by Sridharacharya. And then up to Bhaskaracharya, everybody used that Laksha. And now also we are using Laksha. Tatha, Payutav is Dasha Laksha, Koti, that is the common name nowadays. Aryabhata is 10 crores and Gurudeva is Abja. So Shatakoti, that is 10 raised to 9, 10 raised to 9. So it is mentioned here that Sthanam, Dashigunam, Sya. So the next place is 10 times the previous. That is mentioned here. And Bhaskaracharya gives 18 names up to 10 raised to 17. And Mahaviracharya gives 24 names up to 10 raised to 23. So then, means 24 names starting from 1. So 10 raised to 0 onwards. So Mahaviracharya gives names up to 10 raised to 23. And this is the verse of Bhaskaracharya. And what are the names of Bhaskaracharya? And we can compare these names with the names given by Aryabhata. So you will see some differences. And you will see here the name Laksha, which is available here. Laksha in this verse of Bhaskaracharya. So Eka, Dasha, Shata, Sahasra, Ayuta. Ayuta up to that same names. Then Payuta is replaced by this Niyuta. It is replaced by Laksha. Then Payuta is same. Payuta, Koti, etc. Then Arbuda, Abja, Kharva, Nikharva, Mahapadma, Shanku, Shankava. So Shanku is the name. Jaladhi, Cha, Antya, Madhya, Padartha. These are the names. And also it is mentioned Dasaganotkaram Samkhya. So multiply by 10 to get the next place. So here Abja actually, Abja is here that we nowadays use, and that is the same as Padma. Because some mathematicians use the word Padma, but Padma and Abja, they have the same meaning, that is lotus, and that may be the issue. But somehow Bhaskaracharya has made Abja as popular, and that is being used nowadays. Mahapadma is multiply Padma by 1000. So that is Mahapadma. That is here. Mahapadma. So Abja, Kharva, Nikharva, Mahapadma. So Abja is Mahapadma is 1000 times Padma. Mahapadma. That is usually, if you see Mahaviracharya, I think this will be here. Usually 1000 times that is Mahapadma. So I should list that also, what Mahaviracharya is. Anyway, so these are the in powers of 10. You see here the values of this Koti, Dasha-Koti, these places. And million, billion, trillion, these are common words nowadays. So million is 10 raised to 6, that's a Laksha. Billion is the Laksha and trillion is Mahapadma. And there are Jalati is here, which is 10 raised to 4. Jalati and the Madhya Jalati is C. So actually, Sridharacharya used a similar word, not Jalati. He used Saritam Pati. Sarit is river, Saritam Pati is sound or sound. So that is the word used by Sridharacharya, but although the words are different, the meanings are the same. So the same names in that sense were used by Sridharacharya and all the different mathematicians up to Bhaskaracharya. And after Bhaskaracharya, the same names have been used by everybody.
Is it because of Katre that they wanted to have meters so there will be several words?
No, that has nothing to do with Katre. So Katre only is a way of writing these numbers in words. That's all. Otherwise, that has nothing to do with this thing. You see, actually, these mathematicians have manipulated these names. What they have done is they have started with the names in the Yajurveda. So Yajurveda has basic names. 12 names are there in Yajurveda. And these names, like now Anta is in Yajurveda, you see Anta. Only Anta is in Yajurveda. Then Madhya is there, Padartha is there. But in Yajurveda, the meaning of Padartha is different. So it is 10 raised to 12. So these mathematicians, how they were at different places, how do they want to fight with each other, or somebody else wants this name, so let me do my own name. So we don't know. What are some okay. So anyway, the point is that so Mahavira collective was in between Sridharacharya and Bhaskaracharya. But he himself gave different names because he wanted to go to 24 places. And so he had some Dasha Shata such name in between he used and his names. So his names are different than the names of other mathematicians. Although the initial names they are common. Everybody's Ekam, Kaham, Shatam, Sahasra, all these things are same. Then Ayudha also is same, but now Mahavira started using this Dasha and so on. Dasha Lakshana. These are names which were made popular by Mahavira, and then these were also okay. So now here I want to say something that here I missed this Phala last time. Phala actually means Kshetrapal. So if you use this word,
there is a difference between the English terminology and the American terminology.
Difference in what? I mean,
the naming. Billion
numbers. So million is Dashalaksha. This trillion I mentioned here, that I can say something. That trillion, there was an old meaning of trillion. That was 10 raised to 18. But after 1974, they have, I think, this British people and American, they have agreed to call trillion as 10 raised to 12. After 1974. Yes, that's right. But so trillion has these two. So old it said that it was different in UK. Yeah. But now they are, because of to avoid the confusion, they have agreed that we should use trillion for 10 raised to 12, which is Mahapadma, which is nowadays very useful, but our Marathi papers are not using Mahapadma. Instead, you should use, because now all the taxes and everything is in terms of lakh crore. Mukesh Ambani, how much money he has? So it is 6 lakh crore. That's approximately. It is going up and down. But that is Mahapadma. So you should say actually he has 6 Mahapadma, so many rupees. Dollars is slightly less. The number is so sometimes they make dollars and
if this tradition is given, it will be welcome.
yeah, it's a meeting, but everywhere I'm telling that this is good Mahapadma. People are not listening so far, but we have to do that because we are writing everything. Various articles are writing. So this is promote. That's why I'm telling you. But I have exactly one instance where there is a car, there is an article in which the word Mahaprabhu is found. Is correctly mentioned. Because it is a confusion about the names given by various mathematicians. People can misinterpret the name also. So that's why. But Mahapadma is exactly used for lakh crore. There's an article, and I think I have circulated the other slides. In that I have actually copied that in the slide. So that's the as circulated in my videos. Yes. So they should use this Mahapadma because every time they are going to write this lakh crore and so on, so we can use it. Okay. So now this is fine. Now this hello is there actually in Suvarna and this. So this hello means hello is used for Katre. Hello is actually some value associated to that, whatever is going on. So it is a value associated to that. So that is Katre. So here this is the Varga. Varga means it is Samajapurashraha. And Methalve madam actually can comment on this. Chatura Ashtra and there is Ashri also. So Ashra and Ashri, there are actually here Shankar Abhinda has taken the meaning as a size actually, Bazu, for both of them. So four-sided figure, four edges, and it is a Taurus and square. And Shankar Abhinda has explained that Karna should also, both the diagonals should be same, so that it is fixed, it is a square. Otherwise, if only four sides are equal, then it can be Samabhuja also. Just Samabhuja or yeah. So this is additional thing which is not in the name, the Purasha, but it is understood that he by that he is Chakravarsa. So Varga is used for Samajapurashra and its Phala also. So Phala is the value associated to that is Kshetrapal. We call it as Kshetrapal. And Sadrusha is the Savarga, so multiplication of two equal numbers. Savarga is multiplication. Then Sadrusha Traya Savarga. So you are listening. Sadrusha Traya Savarga. I have to type that. If you take three things together, that is Gana. Tatha Dwadashashri. So Dwadashashri is a cube. Cube has 12 edges. So Ashri is sides and 12 sides are there. So that is a cube. It is understood that we are having all angles 90 degrees, etc. All sides are equal. All that is understood, and probably Dwadashashri is the term used in those days for a cube. So that is that's true. The first one is different. So here question. The first sum is different. So the first one. So many that is Chaturashra and here is Chaturashra specifically and the variation of Chaturashra is Dwadashashri. So Ashri means what I understand of course Sanskrit people or Vedanta madam can tell me Ashri means Ashraya. So it is resting on these 12 edges. So maybe because of that Ashraya, Ashri or Ashraya. But Ashraya has A there, but Ashri he has A there. So that is the same. But these words are used, Ashra and Ashri for size. And sometimes it is used for corners also. So one has to actually see the literature and where these words are used and what is the original word for it. That's right. Tapu Ashra and Varasha Ashri. Varasha Ashri and Tapu Ashra. There is a over there. Yes, Tapu Ashra. All is there. So okay. So I think we can go ahead with this. Now, how to get the square root? So now here and there is also cube root later on. So in a Varga and Ghanamut. So square root and cube root with the terminology which I should make it clear. So this 625 will be classroom.
Control what is the rule as you were saying last time. So 10a plus b square and you compare this.
Yeah, I heard that I did not bring it. There are two things. But 100 is the.
Then I understood. So 10a, that a does not have to be a single digit. It can be many. At 10a plus b, that we write people know. And then from that, we can at least detect the first digit of the square. So that is how you do Varga. And for Varga mode, you have to reverse this process now.
Yeah, actually, what you do, you write the number as suppose you are, I mean, I can explain you.
Yeah.
There is a possibility because here we have a board also. So you can put this thing down. This खाली करो,
Sometimes students in play can also come up with some new thing which is not enough.
I will continue from my class. We write a program to be thinking or you take those activities by expanding because then it is a Q of a biology.
You wrote a program.
P. You need to manage all of it.
I mean, you wrote a program.
That's,
Whiteboard, clear whiteboard.
और तो कुछ
Yeah.
हाँ you can write it. Yes. So from Gita Vedic can be explaining that.
so if you have a number, which I can, suppose I have a 3-digit number. So I write this as D1 into 10 square. Okay. Plus D2 into 10. Yeah. Plus D3 into 1. Okay. So this D1, D2 digits are the digits of the number.
Most teachers, they may.
Yeah. 0 less than.
You just write ABC rather than.
Yeah, so they are between 0 to 9. Now I want to square this number. So how do I square? So first I write D1 into 10 square plus.
This non-zero. So
Yeah.
zero initial or zero.
Yeah. So,
This one can be possible.
so I write this as D1 square plus. I put these two things in the bracket. Okay. And I will square this. So in the next step, what I do, I write this as one term, the other thing as the other term. So my square will be D1 square into 10 raised to 4. Okay, plus D1 into 10 square into bracket D2 into 10 plus D3. Okay, and into, into 2. Usual thing, and plus I will have the last term square, that is D2 into 10 plus D1. Okay, so maybe this is the additional.
D3. Last one.
Yeah, I had put it here.
And then square.
Square of that. So this is a square plus 2ab plus b, the usual expansion. Now when I work this out, this d1 square, it will have the power 10 raised to 4 as the multiplier. Okay. Then the next power of 10 that will come from this term. So it will be 2 d1 d2 into 10 cube. Okay, then the next term will be 2 times d1 d3 into 10 square. And then I have, so for time being, I keep this square as it is, d2 into 10 plus d3 and whole thing square. So now I look at this term, which is d1 square into d1 square into 10 raised to 4. So whatever are 10 raised to these terms, they have the power 10 raised to 3. So 10 raised to 4 means it is 10,000 term. Term associated with 10,000. So if this d1 square is single digit, then this will be the term associated with 10,000. And if it is double digit, only 2 square and 3 square are single digit. 1, 2, 3 square. 4 square onwards, it will go into double digit. So that will be the term associated with 1 lakh.
Can I suggest one thing? You write that odd even with the power.
Yeah. So now
Then it will be.
yeah. So what I have to do is that from this logic, I have to suppose I have a number. Now I am using different notation.
That is the next part.
Alpha, beta, gamma, delta, pi, psi. I'm squaring 3-digit numbers, so it can be 6 digits. So now I have alpha. So from alpha, how do I conclude about t? That is the question. See, we have this number as the square. So what are we trying to find out? We are trying to find out square root. So I know alpha. So from alpha, can I conclude about d1? That is the thing. Yeah. So what will the squares place, it comes here, or 100 is the square, so it will come here, or, and then these things are not simple because d1 square into 10 raised to 4 will have also whatever is carried forward from this term. Okay, so when we subtract that square, which is that d1 square, we multiply the, see, then we know d1, so we divide it by 2 d1 and get to the next thing, that is d2. But that d2 will not be alone, it will have some d3 part also. So when we subtract that, that d3 can be identified, like that we go on.
Yes, may I?
So that's why we have that thing, what we call in Marathi as pette parameter. So Vishama. Yeah.
So just one comment that this 2d1 is here, 2d1, which is used later on, means to divide that one.
Because we divide by
Suppose my notation is bit different because I don't know what is further. So
yeah, that's what we do.
So suppose I go to F5, and there are 6 digits. So what she was saying is, this A5, A4 as a number, that is 10 A5 plus A4 you consider, and take
The square root.
take its square root, means the integral part. And so you are what is the integer part.
Audio is not there in the problem.
Okay.
This could not be connected.
So the first thing we have calculated. So A5, A4 minus
connected.
I will call it say
Let's
D3
Yeah.
square. Now I get some number. Let us call it say E1, E2. E1 may be 0 or may not be 0. Now what is the next thing is
We have to multiply by the.
I have taken this. Now there can be a problem. Why? Because now you are going to say that I am going to divide by what was the previous square D3. So I will divide by 2 D3. And whatever is the complete this thing, say suppose I will call it as D2 tilde. Why tilde? Because now what happens? Sometimes 2 D2 D3 tilde and this difference, and then you are going to take a square. You are going to bring that, and then you are going to take a square, but that subtraction may be negative. So you have to come back and say D2
-1.
minus. Now the question is why only -1 will suffice?
मी करून पाहिजे तर काहीतरी तुम्ही मायनस पण करायला
लागतं.
हो सॉल्व केलं
मी अजून तशी बेस मला आली नाही.
एक किंवा एक स्टेप होते काम होतो
ऑब्झर्व करायला सॉल्व ऍक्च्युली करताना नेक्स्ट टाइम ऑब्झर्व करायला लागतो की तो स्क्वेअर सबट्रॅक्ट होईल की नाही
सबट्रॅक्ट होईल की नाही हे बघायला लागतं.
पण कमी करायला लागेल See, actually, that is below from the other.
Exactly. That can be less.
That can be less or more.
आणि सरांचं असं म्हणणं होतं आता ते त्या काय मागच्यांनी सांगितलंय असं नाही पण जर का हे जायचं असेल डेसिमलला काढायचं असेल तर इथे डेसिमल पॉइंट आहे अगेन सो चुकलंय का मला नाही इथे अजून एक घ्यायचं म्हणजे इव्हन नंबर ऑफ घ्यायचे त्याच्यामुळे हे वरचं फक्त बघावं कमी करता येतं तुम्हाला हलकी आहे. हे म्हणलं इरेज करायचं नाही मी इरेज केलं तो now you do the same procedure. So now you have 16 here. So 1 here, I get 4, then I get 10. Now the decimal, because I have shifted from, I have gone beyond decimal. So 2 into 4. So I get 1 here, 8 here, 2 here, now 20. Barabar na? So I have this 1. So now I have to consider 2 into 41, that is 82.
कनेक्ट झालं
But you want to understand why I'm working.
Why is working? Correct.
Yeah, that is what was under the
That's how
It started with the digit number and it's square.
No, we can do it.
We can go.
You can see.
We put out one way, where is your
And one of the human mind is.
Then we can give the one thing.
And for a bright student, you see what are the corresponding books for a binary. That's a very different problem in terms of our. So for a binary, for a number is written in the binary.
Binary.
No, this is actually very important question.
Yeah.
And there is a problem of algorithm also. The problem is find the square root of a number. That is the problem.
Now,
This is actually binary.
Hello.
here, convergence is faster. It's like a one day.
So anyway, we'll think about later on. The problem is region, that's why I'm saying. Okay, so I will use it and let us see if people can listen. Hello, hello. Yes, I think people can listen. Okay, so now I have to put this down. त्याला काय कराल desktop, yes, yes. Desktop is here, I can click on that. Yes, and then हा इथे आहे ही ओपन करायचं ते पण तुम्ही ओपन केली असेल खरं ना आता मी क्लोज केले ओके ओके सो I think people are able to listen better is what we expect. Okay, so now the names here
actually, medical madam has just mentioned this, that this is, so this is Vargasthana, this is Avargasthana, this is Vargasthana. So this is for square roots. For cube roots, this is Ganasthana, this is first Aganasthana, this is second Aganasthana. Again, this is Ganasthana, then if there is something, first Aganasthana, second Aganasthana. So Varga Ghana, then Avarga, then Aghana, but Aghana there are two, because three things you are taking together. So Aghana 1, Aghana 2. So like that. So now here Dvigunena Vargamulena is something 2 times the Vargamula. So here first of all, here this is the Vargasthana 6. So from that, so this can be 1 digit, or you may have to use the other Avargasthana also. But last Vargasthana is this 6, and then there is 0 here, we can say, if you like. From that you subtract Varga, that is 4, and then 2 is remaining. And the square root of 4 is 2, which is to be written in the answer. And here Dvigunena Vargamulena, the Vargamula of 4 is 2, which is written here. Multiply that by 2, and then you divide. So divide, and then 5 is the quotient, and multiplication of 4 into and 5 is 20, and 2 is remaining. After that you take the number 5 from this. So this is Avarga we had taken. When you take Avarga, from that you have to subtract this 2 into 2 multiplied by 5. That you have to subtract from Avargasthana. And once you do that, after that you get this Vargasthana below. Then from that you should subtract square. So 25 you square, and then it becomes Shuddha here, fortunately. That is, no remainder is there, remainder is 0. So that gives you this square root 25. So basic idea is, Vargasthana if it is there, then you should subtract a square. And Avargasthana is there, then you divide by 2 times square root. These are the 2 steps. That is what he is mentioning in general. These 2 steps. So initially we have Vargasthana here, that he is not mentioning here actually. At the beginning he should mention, but he is not mentioning. So what happens? So I think this is common sense. Everybody is thinking that common sense is you subtract the square from that, first of all. So do that, and then you get Avargasthana. So Avargat, here there is Avarga. From Avargat, you should use this Dvigunena Vargamulena. So 2 times this square root, that you should use. Then you should divide this by this, then there is 5 quotient, and then product of these 2 is 20, that you should subtract. That is how the somehow meaning. So Avarga is to be treated in this way, and Varga should be treated in this way, that you subtract a square. So here it is Vargasthana, you subtract a square. Here there is Vargasthana, you subtract a square. That is what the procedure is. But still, of course, you have to, as far as Sanskrit is concerned, you have to be, you have to work more, I think, to get to exactly fit the meaning which is given here.
Actually, somewhere.
He himself knows it and he doesn't say anything. People know, yeah. Knower, they only make up this, then it will come to their mind, because he only has to write kind of in short. So Varga, these things are there. And now Ghana, our Aghana is that is what he is using now after this. So this is one example in which 6 is Varga, 5 Varga. So 5 is a Vargasthana, subtract a square in that case. And then you get this 1, then you take Avarga. Now once you get Avarga, you have to immediately take the square root of this, multiply that by 2, and this again comes out to be 4. Divide by that, get 3 as quotient. Product of these two is subtracted here, and we get 2. Then you take this vargas, 7 is what? Vargastan. So 7 is vargastan, therefore you subtract this square. 3 square is subtracted. Only 3 square is subtracted. Now not 4 square. But that whatever that number is, yeah, 3 is there. So I just forgot that. That 3 its square one has to take here. So 9. So that one has subtracted, and then 18 is remaining. Then you take avarga is 5. Then you have to take this 20 up to 23 you have come so far, because 2 we added at the beginning and 3 you have just added. So 23 into 2, that is 46, and you divide by 46, and then you get 184 here, as 46 into 4 is 184. 1. Then last is vargastan is 6. So you subtract square, and then everything becomes, remainder is 0. So you stop here, and this is the vargamul. So this is fine. Then now this is ghanamul. I had an example of what is it here? No. Find the cube root of this number. Just if there is some decimal, we can do some. Okay, anyway, so let us look at this ghanamula. So now the time is also almost over. So, but at least now the terminology is clear that here 17576 is ghanasthana, aghana, ghana, 7 is ghana, and 1 is aghana. So aghanat bhaje dvitiya. He directly starts with that second step. That is the point. That the first step is you should subtract a ghana from that, right? This he has done in the previous verse also. So dvitiyat aghanat. So what is dvitiya aghana is? So this is ghanasthana, and this is dvitiya aghana. Aghanat bhaje dvitiya trigunena ghanasya vargamulena. So first of all, one is subtracting a cube. So that step is understood by everybody. That's it is not mentioned here. Okay, so 17 minus 8 is 9. Now 5 is dvitiya aghanasthan, because 7 is first, 5 is dvitiya, second. Okay, so once you have that, you should trigunena ghanasya vargamulena. So this 7 was ghana. Mula vargena. Mula is that cube root, and you should, mula is cube root, and take the square of that. So 2 square. So trigunena means multiplied by 3. So 3 into 2 square, that is 12. Now you divide this by 12 and get the quotient 6. That 6 is written here. So first of all 2 is written, then 6 is written. Now 72 is subtracted and you get 23, and then you get 7 here. So 7 is the first aghana. 7 is first aghana. So there the operation is different. Means here when second aghanasthan was there, dvitiya aghanasthan, then you had 2 square into 3. But this is the first aghanasthan. So the operation is different. So vargas tripurva gunita. So purva is 2 and then 6 square and multiplied by 3. 3 purva gunita. So varga of this 6. That's what I have understood. Multiplied by this previous 2 and then 3. So that is 216, and 216 is subtracted and you get 21. Then this Ganasthana 6 you are taking, and then 216 is subtracted, that is 0. So that is the answer. So Ghanamula we have got as 26. this 6 which you have got here, that actually works, and 26 is the Ghanamula. Yeah. Yeah. Cube. 3a square b plus 3ab square. Correct. Yes. Yeah. Hmm? 12 into 7, that should be subtracted. That's, you are right, that why not 7? So here is one example where that didn't work, because if you do that, then later on you will get some negative numbers. You will get some number here, and if you subtract, you get a negative number later on. So you have subtracted something which is actually giving you the result later. So there are possibilities of this type. Sometimes the quotient they should choose properly, not the maximum possible. Okay, not the maximum possible. Yeah,
Is much higher than your 11,117.
correct.
So you have to go back.
Go back. Yes.
I want to find P.
Yeah, right. So yeah. So what you are saying is right, that if you, this is not the usual division, if you do, then I should put 7 there instead of 6. That is right. But here you should choose that quotient in such a way that it will go ahead properly. So what one does is, first of all, one tries 7 here and 84 one writes there, and then goes ahead. In the next step, you will get this number larger than this. Okay. So it is a negative remainder, which we go back. So the algorithm goes forward and backward actually, but you do not have to do much like this. Maybe you have to go back only one step, or you were saying 2 steps sometimes. 2 steps means that number, like for example, instead of 6, maybe 5 is required. For example, like instead of 7, you have taken 6, but probably she is saying that there are examples where 5 also may be required, one previous number. Up to that, there has been some, because this whole adjustment, and you can theoretically get some bounds also. If this happens, then you do use this and so on. So that these are some things. That is also true, that for cube root, or if you want, so especially this happens when these numbers in the square root or cube root are large numbers, like 8, 9, etc. Such numbers are there in the square root and cube root, then such a thing can happen. Yeah, in the computer algorithm, you have to do like that. So you don't have lecture now because you have given the lecture to other teacher. So we can. He has 5 lecture. So last time we stopped exactly at 5 o'clock. But here I can. So anyway, this. Okay. So this is how you can do. So now more examples we should see. So this is 17.676. This is, you have to find out the cube root of this. So Answer is 2.6 for this. And this is approximate cube root. So one can try like this, that take 17656. 5.6. 5 cube is, no, there is I think some mistake probably.
No, you have given the answer of that.
Or you,
Different.
this is different. I think. This is okay. Now this is different, slightly different question. Yeah. Answer of this is this. That's right. And this is slightly different question. So find the cube root of this number. Yeah. This is I think perfect. This is perfect cube of this. But this is not perfect cube of anything. So now one tries how to do that. So for 176, first of all, 5 raised to 3 is 125. You subtract that. And you get 51. 51. Then you should 51. Then you should take what? 7.
That's
7.
That here. That 7 is here. Yeah, okay, 7. That one is taking. Now square root of this is 5. Cube root of this is 5. 5 square into 3 is 75. Divide by that, you get quotient as 6. Then that 6 you are writing here. Then 450 is 676. Means 667 only you are getting. Then 6 from top you should take. Then you should use this 6 square into 5 previous one and 3. So it is 540, which you should subtract. Once you subtract this, you get 136. 136, and now after that you can go on taking 0. So 760. So that 0 is Ghanasthan actually. So you should subtract a cube after this. So you get, and that is subtract a cube, and cube root of that is 6. So we can write 76 here. Sorry, where is that? 5.6. 5.6 already we have written. This 6 we have already written here. Yeah, this 6 come from there. There only. 5 you immediately get, and this 6 one gets back quotient. So 5.6. Now after this, quotient is written there. In the previous thing also, next digit, see, here the quotient is 6, and that is written here immediately. See, first of all, 2 is written, right?
Then you divide by 2. So quotient is 6.
That 6 is written here immediately. That one gets immediately. That digit. That B we get immediately. So same thing. So what we are doing here is that first of all you get 5, and then you get 6 from this. This 6 is written here, and that 6 is used here, 6 square, 6 cube, and so on. That is subtracted, and you get this. Now if you want to go ahead, then you have to put additional 0, 0, and so on, and then next quotient and so on one has to see. But so far we have got only this 5.6. This 6 is everywhere used in all the 3 steps, and you catch it in that step. So
You have not 3 zeros.
3 zeros, yeah. No, actually what happens is you can put only 1 0 there, and because that 0 gives you essentially almost that next division, and next digit one gets.
Like previous.
Yeah, but then there will be a correction there, because as was discussed, suppose I divide by, quotient is 7, but I may have to take 6 or 5. So I have to go ahead and check. So that's why next 3 steps one has to carry out to get the next digit. Yeah. So approximate digit one can get immediately in the next step. So that is, I think, now Ghanmul. One more example I have taken that find the Ghanmul of this larger number. Just to check what is happening. So one is Ghanasthana, 0 is Ghanasthana here, and 7 is Ghanasthana here. These 3 Ghanasthana are there here. So 1 cube subtract 1, you get 0. Then I get 8 here. Then 3 into 1 square, that is 3. You should divide by this 3. So quotient is 2. So you multiply 3 and 2, get 6. Remainder is 2. Then you get next number 6. And then 3 into previous 1 into current is 2. 2 square. That you should subtract 12. Then you get 14. Now 14, now you must take after that 0, which is here. At 0 you should take. Now 2 cube is 8, you are subtracting the cube of this. Then you get 132. 132 on that you take 8 here. Now this is the next step after a Ghanasthana. This is the Dvitiya Aghanasthana. Because Ghana, Aghana, Aghana. 8 is second. So there you should have this 3 into 12 square. Now this is 12 here. So in this step you should take the square of 12, not just 2. That is the point. So 12 square multiplied by 3, that is here, written here. So 432 is the by which you should divide. Then you get quotient as 3. So this 3 I should write here unless it is corrected. You can write there. So now this into this is 1296. From that, now you take the second, next thing is 6. That 6 you are writing here. Here I think 6 is here. So 33 to 6. So 3 into 12 into 3 square, that is 324. So you get 2 here. And the last Ghanasthana is 7. So you subtract a Ghana from this cube and you get 27. And this becomes reminderless. Remainder is 0. So there you are stopping and you are getting 123 as the answer. So in the next step, you have to use these numbers here 12. And if you want to go ahead, then you should use 123 into 123 square into 3 like that in the next step, following step. So that is so I think probably Ghana is over. Yeah. So we can stop here. So Vargasthana, Avargasthana, Ghanasthan, first Aghanasthan, second Aghanasthan. So that is how he has done, and every time new digit is taken and this process is there. And as we have seen in the previous example, we have to use the quotient properly sometimes. That is also some lesson.